It's on the back. Okay, the first proof right here. So remember, anytime you have a proof, you always want to plug in the given first. So those are easy points. You just plug in the given right here. So angle 1 is congruent to angle 2, and the reason is given. Then the proof statement always goes in the last spot, so we can plug that in as well just to maximize our points. L is parallel to M. Okay, so now what we're going to do is look at the relationship between 1 and 2. It looks like they are corresponding angles. Yes, if corresponding angles are congruent, then we can prove that these lines are parallel. So it's the converse of corresponding angles postulate. Or on Alex, it literally just states it out. If corresponding angles are equal, then the lines are parallel. Okay, the next one, we're going to do the same exact thing. Fill in the given first, just easy points to get that right. Angle 1 is congruent to angle 3. Reason given. And then the proof statement goes in the last line. L is parallel to M. Oh, I need a 1 here. Okay, so we have 1 and 3 right here. We need to recognize their relationship. 1 and 3 are alternate interior angles. If alternate interior angles are equal, then yes, the lines are parallel. So it would be the converse of alternate interior angles theorem. Yes. It has to do with how proven they are. I don't know. I could Google it. Like a theorem's more proven than a postulate, but we accept both as true. Postulate versus theorem. Give me the shortest and simplest definition. I like AI. Okay. It didn't even give me a simple definition. A postulate is a statement assumed to be true without proof, serving as foundational building block, while a theorem is a statement that has been proven true through a series of logical steps in established postulates, theorems, and other theorems. I don't know if that's more clear or less clear, but so any like if-then statement, you could have the converse of. So if these angles are congruent, if corresponding angles are congruent, then the lines are parallel. And you could say that if the lines are parallel, then those angles are congruent. Anyways, you don't have to like understand the little details. Like the main thing in geometry is just recognizing the vocabulary. Because even different textbooks sometimes use the vocabulary a little bit differently. So as long as you know the vocabulary, you don't have to remember whether it's a postulate or theorem. Just like corresponding angles mean that the lines are parallel, or parallel lines, you have corresponding angles equal. So that's all you have to know. Cool. Okay. Okay, then here we have the given. So always plug that in the first line first. Looks like they already filled it in here. We just have to write given. And then the proof statement, make sure it's in the last line, which it is. Okay, then it says 1 and 2 form a linear pair. We can see right here that 1 and 2 come together to form a straight line. So that is just definition of linear pair. If two angles are adjacent and form a straight line, then they are a linear pair. Then the next one, it says that 1 and 2 are supplementary. Supplementary. So if you have a linear pair, then they are supplementary. So that is linear pair postulate. Okay, and then The next one, the reason is congruent supplement theorem. What that means, I think it came up last chapter or something. Congruent supplement theorem. Supplement theorem. Okay, congruent supplement theorem means that if angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, they equal 180, then angle 1 has to equal angle 3. Should have used the numbers they had up there, but I didn't. Okay. Anyway, so like 1 plus 2 is 180, 2 plus 3 is 180, so therefore 1 and 3 must be equal to each other, because with angle 2, they equal 180. So that's the reason for the next one. So congruent supplement theorem. Congruent supplement theorem. So in this case, just to further, like 1 and 3 are supplementary, so angle 1 plus angle 3 is 180. And then we said angle 1 plus angle 2 is equal to 180. So therefore, 2 and 3 are equal, which is what they have here. And then from there, it says that lines are parallel. 2 and 3 are corresponding angles, which means if they're equal, then our lines are parallel. So that would be the converse of corresponding angles. Angles postulate. Okay, and then the last one, plug in the given first. L is parallel to M, given. This one, they split up the given into 2 parts, which sometimes they do. So angle 6 is congruent to 11, that is also given. And then we want to plug in the proof statement in the last statement here. So T is parallel to S. And so already we have half of the blanks filled in. It's also helpful to like label it on the picture here. So 6 and 11 are equal. That was given. It also says that L is parallel to M. Okay, the next statement says that 6 is congruent to 3. Well, 6 would be congruent to 3 because they're alternate interior angles, and L is parallel to M. So alternate interior angle theorem. And then 4 says 3 is equal to 11. Okay, well, 6 is equal to 11, and 6 is equal to 3. So therefore, 3 must equal 11 because of transitive property. And then from there, if 3 and 11 are congruent, those would be corresponding angles, which would make T parallel to S. So that would be converse of corresponding angles theorem. Okay, so you guys have a lot of time. Please, if your notepad is complete, turn it in. I'll quickly grade them and get them back to you. You're going to go on to Schoology and do homework 3-9, and then work on your ALEKS and finish that.